right now, there is one experience happening: the sound in the room, the weight of the body against whatever holds it, the faint thread of thought moving underneath, half formed, already dissolving. All of it is given at once, not assembled, not stitched together from separate streams, but simply, immediately, here is one field, one knowing, a wholeness that does not wait for its parts to arrive, and there is no place in the brain where this happens. This is not a poetic claim. It is a structural fact, and it is one of the oldest unsolved problems in the science of mind. The brain is not a single thing. It is roughly 86 billion neurons, firing in different regions, at different speeds, with no central chamber where the signals meet. The region that processes color is not the region that processes motion. The sense of where the body sits in space is computed in one place, the sound of a voice in another, the meaning of a word in a third. These processes do not happen at the same instant. They do not happen at the same location. There is no single moment, anywhere in the architecture of the brain, when all of it is present together. There is no neuron that watches all the others. There is no inner room where it converges. And still, this is the strange part, experience remains one. In the 17th century, the philosopher René Descartes went looking for that room. He needed a single point where the divided machinery of the body could meet the undivided soul, and he settled on the pineal gland, a small structure near the center of the brain, unpaired, alone, unlike the mirrored organs arranged symmetrically around it. He was wrong about the gland. But the instinct behind the search was not foolish. Something in the structure of experience insists that the unity must come together somewhere. It does not. 3.5 centuries of investigation have found no seat, no center, no convergence zone. The signals stay distributed, the processes stay separate, and yet the experience is whole. The problem has a name. Neuroscientists call it the binding problem. How do separate streams of neural processing become one unified perception? Philosophers call it the unity of consciousness, and they have been circling it for as long as philosophy has existed. The American psychologist William James, who in 1890 wrote the book that founded the serious scientific study of mind, circled it carefully and could not close it. The question is simple to state and brutal to answer. How does a system made entirely of parts produce an experience that has no parts at all? And it deepens from there. Because consciousness can, in fact, be divided, just not in the way anyone expected. In the 1960s, the neurobiologist Roger Sperry and his student Michael Gazzaniga studied patients whose two brain hemispheres had been surgically separated, the great bridge of fibers between them cut to stop the spread of severe seizures. What they found was unsettling. Under precisely controlled conditions, the two halves of such a brain could know different things, want different things, respond differently. As though one skull now held two centers of awareness, each blind to the other's knowledge. Sperry would receive a Nobel Prize for this work, and it tells us something exact. Consciousness can be split. A surgeon can take a scalpel to it and produce two. But here is the thing the scalpel cannot do. Within each half, within each of the two divided minds, the unity is again total, seamless, complete. You can cut the field in two, and neither piece is a fragment. Each piece is, once more, a whole. You can divide consciousness. You cannot find the parts it is made of. Every time you cut, what you hold is another indivisible. Hold that shape. It will return. There is exactly one other place in all of nature where this structure appears. Not a resemblance to it. not a parallel that requires interpretation. The same shape, appearing at a different scale, in a different domain, discovered by a completely different method. At the foundation of the physical world, beneath the level of atoms, beneath the level of solid things, there are systems that also cannot be divided into independent parts, not because the instruments are too crude, but because the parts, as separate things with separate properties, are not there to be found. The physicist Erwin Schrödinger gave this a name in 1935. He called it entanglement. Take two particles that have interacted and let them fly apart, across a room, across a city, in principle, across any distance. Quantum mechanics says that under the right conditions, everything that can be known about the pair, the whole, considered as a whole, is fully specified, and still, nothing whatever can be said about either particle on its own. The information does not live in the parts. It lives only in the whole. The parts, separated and considered individually, do not have definite states to report. Schrödinger did not regard this as one curious feature among many. He called it the characteristic trait of quantum mechanics, the single thing that forces its complete departure from everything classical physics assumed about how the world is put together. Albert Einstein could not accept it. He called the link between separated particles spooky action at a distance, and he spent his final years convinced the theory was incomplete, that there had to be some local hidden information carried quietly inside each particle, that the formalism simply hadn't yet found. In 1964, a quiet Irish physicist named John Bell turned that conviction into an inequality, a precise mathematical bound that any locally real theory would have to satisfy. And the experiments came. In 1972, and again in 1982, and then in 2015 with every loophole closed. And in 2022, the Nobel Committee named this result explicitly in awarding its prize in physics. The verdict after 60 years of testing is unambiguous. There is no hidden local information. The connection is real. Einstein was wrong. The whole is real. The parts are not separable. So look at the shape that has appeared twice now in two domains that could not seem further apart. In the mind, a unity that can be cut but cannot be reduced, divided, and you hold only smaller wholes. In matter, a unity that can be measured but cannot be separated. Interrogate the parts, and they have no independent existence to report. One structure asked by neurons. The same structure asked by particles. The same wall at the bottom of two investigations that began from completely different places. This is the point where someone usually arrives to explain what it all means. To take these two facts, the indivisibility of awareness and the non-separability of the quantum, and press them together into a single triumphant conclusion. It is worth pausing there. It is worth being precise. It is often said that quantum physics has proven that consciousness creates reality, that the mind of the observer collapses the wave of possibilities into a single definite fact. That attention is what makes the world solid, that without a mind to look, nothing is really there. This framing appears in popular books, in documentary films, in the titles of earnest online courses. The actual physics is stranger and more disciplined, and considerably less flattering to the person who wants to feel cosmically powerful. The word observer in quantum physics does not mean a conscious mind. It means a measurement, an interaction, a physical coupling between one system and another. A photographic plate observes, a current in a wire observes. A single oxygen molecule colliding with another particle in the dark observes, in the precise technical sense the equations require. The involvement of a conscious subject is not what the mathematics specifies. whether the quantum wave truly collapses at all, and if so, when and by what mechanism and why, is not a settled fact dressed up as mystery. It is one of the genuinely open wounds at the foundation of physics, open now for 90 years, called the measurement problem. And every serious physicist knows it is not closed. The fantasy that private human attention manufactures the world is not what the equations say. What they say is harder to hold than that, and we will hold it slowly. Because the real question, the one the numbers are actually pointing at, is older and stranger than any of these popular versions. Whether what lies at the foundation of things is one or many. Whether the separateness everywhere visible to the senses is the truth of the world or only its surface. Whether the divided and the undivided are two kinds of reality or the same reality seen from two different distances. These are not new questions. They are not questions that physics invented. They arrived in other languages, through other methods, in other centuries, in traditions of inquiry so different from particle physics that they seem to belong to an entirely different form of human life. And yet the structural question they came to, through meditation rather than mathematics, through decades of trained attention rather than decades of controlled experiment, points at the same wall. They will come into the story later. Not yet. For now, they are only a shadow at the edge of the room, a suggestion that the question being asked here has been asked before from the other direction, and that those who asked it left behind a record of what they found that is not easy to dismiss, and not easy to misread, though most readers do. The story begins with the problem that would not go away. A problem the founders of quantum physics tried for decades to make small, to localize, to explain into silence, and found they could not. A problem about what happens at the exact point where the unbroken wholeness of quantum reality encounters the unified field of a conscious mind, and whether, at the very bottom, those are two things meeting, or one thing that was never divided and has simply found two ways to describe itself. No one has resolved this. The question is not closed. What follows is its honest shape. The story begins in the mind because that is where the question is unavoidable. Not in the laboratory, not in the equations. In the raw, unignorable fact that sits at the center of every moment of waking life, that there is experience, and it is whole, and no account of the mechanism that produces it has yet explained either of those two things. William James saw this clearly in 1890, in the book he spent 12 years writing, the book that gave psychology its shape. James was not a man given to mysticism. He was a rigorous empiricist, a trained physiologist, and deeply suspicious of anything that could not be pinned to an observable fact, and yet he came to a wall he could not go past. He named it the stream of consciousness, the continuous, flowing, unified character of awareness that is simply given, with no explanation of how the fragmented machinery of the nervous system produces it. He could describe the stream. He could not explain the unity that made it a stream rather than a collection of separate events. He moved on. The wall remained. The brain, examined carefully, is an assembly of differentiated parts. By the latter half of the 20th century, neuroscience had mapped these parts with considerable precision. The visual system alone is divided into more than 30 distinct processing areas, each handling a different aspect of visual information: color, motion, shape, depth, object identity. These areas are anatomically separate. They operate in parallel. They do not operate in perfect synchrony. The signals that leave one area arrive at another with a small but measurable delay, and at the top of the processing hierarchy, there is no final cortical area, no master region, where all the signals converge into a unified representation. The anatomists have looked, the neurosurgeons have explored. The convergence zone is not there. And yet when the eyes are open and the room is lit and a friend is speaking, all of this arrives as one experience. The color of the coat and the movement of the hand and the meaning of the word and the feeling of recognition, all simultaneously present, all bound together into a single unified now. This is the binding problem. It is not a confusion about words. It is a structural gap between what we know about neural processing and what we know about experience. The processing is distributed and sequential. The experience is unified and simultaneous. How that gap closes is not known. Several proposals have been offered. The most influential holds that the binding is achieved through synchronous neural oscillation, that neurons in separate regions, when they are processing aspects of the same object, begin to fire at the same frequency, and this rhythmic synchrony is what ties them together into a single percept. The German neuroscientist Wolf Singer, working at the Max Planck Institute in Frankfurt through the 1980s and 90s, produced evidence for this view. The gamma oscillations he measured, rapid rhythmic firing in the 40 Hz range, did appear to bind information across separated cortical regions. But the proposal ran into difficulties. The synchrony was real. Whether it was sufficient to explain the unity, whether oscillating together is the same thing as being experienced as one, was not demonstrated. It explained a functional correlation. It did not close the gap. The gap has a name, too. The philosopher David Chalmers, at the Australian National University in 1995, drew a line inside the problem of consciousness that has since become the clearest way to see where the difficulty lies. He called one side the easy problems, and by easy he did not mean simple, only tractable. The easy problems include explaining how the brain discriminates stimuli, how it integrates information, how it focuses attention, how it reports its own internal states. These are genuinely hard scientific problems, demanding decades of work. But they are the kind of problems that yield, in principle, to the standard methods. Map the mechanism, trace the circuit, describe the function. The other side he called the hard problem. Why does any of this processing feel like something? Why is there an inner character to experience at all, rather than all the same processing happening in the dark, with no accompanying light of awareness? No amount of functional explanation visibly entails the answer. You can describe every neuron. You can trace every signal. And the question of why there is something it is like to be the system doing all of this remains untouched. This matters because it marks the territory precisely. The binding problem and the hard problem are not the same problem. The binding problem asks how unity is achieved across a divided system. The hard problem asks why that unity, or anything, is experienced at all. They share a boundary. They point in the same direction. And together they mark a region where the standard tools of neuroscience, and perhaps of physics as commonly understood, have not yet reached. So let the mind rest on that gap for a moment. It has a particular feeling when you locate it honestly. The sense that the explanation, however detailed, hasn't yet touched the thing it was supposed to explain. That feeling is not ignorance. That feeling is the problem itself, recognized. And here physics enters, not because it has the answer, but because it has the same problem. Quantum mechanics arrived in the 1920s and immediately produced a question about the nature of physical reality that has not been closed since. The question concerns what is sometimes called the measurement problem, and understanding it requires first understanding what quantum mechanics actually says about the state of a physical system before it is measured. The standard story begins with the wave function. In quantum mechanics, a physical system is described not by its definite position, velocity, or any other classical property, but by a mathematical object, the wave function, that encodes the probabilities of different possible outcomes if the system is measured. Before measurement, the system is said to be in a superposition. It does not have one definite value of a given property, but rather exists in a spread of possible values simultaneously, each with a certain probability. The famous example is the electron that passes through two slits in a barrier. The electron does not go through one slit or the other. In a precise mathematical sense, it goes through both. The evidence is in the interference pattern it produces on the screen behind the barrier, a pattern of alternating bands that is the signature of a wave phenomenon, not a particle traveling a single definite path. The trouble comes when measurement happens. When a detector is placed at one of the slits to determine which path the electron actually took, the interference pattern disappears. The electron is now found at one slit or the other. The superposition has given way to a single definite outcome. The wave of possibilities has, in the standard language, collapsed into one fact. What caused the collapse? The equations of quantum mechanics do not say. The wave function evolves smoothly and deterministically according to the Schrödinger equation. But that smooth evolution does not produce collapse. Collapse is an additional postulate, bolted onto the theory, which says that when a measurement happens, one outcome is singled out. But the mathematics does not specify what counts as a measurement, or when exactly the collapse occurs, or what physical process is responsible for it. This was made precise by the Hungarian-American mathematician John von Neumann, who in 1932 wrote the first fully rigorous mathematical formulation of quantum mechanics. Von Neumann showed that the chain of physical interactions leading from the quantum system to the measuring device, to the recording instrument, to the eye, to the brain, could, in principle, be described quantum mechanically at every stage, with no definite point where the superposition was resolved. He called the boundary between the quantum description and the classical outcome the cut. The cut could be placed anywhere in the chain without changing the experimental predictions. The theory, in other words, does not tell you where the quantum world ends and the classical world begins. The boundary is real. Everyone agrees a definite outcome occurs, but the theory offers no mechanism for producing it. The measurement problem is this: the gap between the smooth quantum evolution and the definite outcome, the unexplained collapse, the cut that can slide anywhere. And here the mind enters physics in a way that was serious, not frivolous. In 1961, the Hungarian physicist Eugene Wigner, who had worked alongside von Neumann and shared his mathematical rigor, published an essay called Remarks on the Mind-Body Question. He had been thinking carefully about where the von Neumann cut must ultimately fall. His reasoning was careful. If every physical system can be given a quantum description, then the measuring device and the human observer's eye and the neural signals in the brain can all be described quantum mechanically, keeping the superposition alive indefinitely. The only thing that cannot be given a quantum description, Wigner proposed, is consciousness itself. Consciousness, as the locus of subjective experience, is not a physical system in the ordinary sense, and it is therefore the natural candidate for what actually terminates the superposition. The wave collapses on this view when a conscious mind receives the information. Wigner illustrated this with a thought experiment. Suppose a colleague, Wigner's friend, is in a sealed laboratory, performing a quantum measurement on a particle. From inside the laboratory, the friend gets a definite result. From outside, Wigner himself has not received the information, and so from his perspective, the entire laboratory, friend, apparatus, particle, is in a superposition of all possible outcomes. Two descriptions of the same situation, both internally consistent, incompatible with each other. The paradox is clean. It shows that the question of where the cut falls is not merely technical. It is bound up with what counts as a knower. This is the historical root of the idea that consciousness collapses the quantum wave. It is worth being clear about what happened to it. Wigner himself, in the years that followed, stepped back from this interpretation. Not because the logical argument was flawed, it was not, but because he found it difficult to accept the implication that consciousness occupied a special physical role, distinct from all other systems in nature. He moved toward a view that the paradox reflected a genuine incompleteness in the theory, rather than a privileged role for mind. And the physics community, by and large, followed a similar trajectory, not because the measurement problem was solved, but because the proposed solution required giving consciousness a status in physics that most physicists were unwilling to grant. The problem was left open. It remains open. The Wigner's friend thought experiment has recently been updated by the physicist Czeslaw Bruckner at the University of Vienna in 2018 into an experimentally testable form, and the implications remain troubling. The point, held precisely, the measurement problem is genuine. The role of mind in resolving it is not established and not ruled out. Anyone who tells you it is settled, in either direction, is telling you what they prefer, not what the physics shows. So physics, in trying to describe the behavior of matter at the smallest scales, arrived at a question about measurement that it could not answer. And in trying to answer that question, it touched the edge of something that looked very much like what consciousness does, or at least like what consciousness is for. And that edge, for a long time, was where the inquiry stopped. Not because the question was answered, because it was uncomfortable. There is exactly one more piece of the physical picture that needs to be in place before the discomfort can be understood clearly. The piece that Schrödinger named, the one that Einstein called spooky. And this piece has already appeared briefly in the opening of this account. But it deserves to be opened fully here, because what it actually says is not what most accounts of it say. Entanglement deserves its mechanism named precisely. The EPR paper, written in 1935 by Albert Einstein, Boris Podolsky, and Nathan Rosen, was intended as a demonstration that quantum mechanics was incomplete. The argument was specific. Take two particles that have interacted and then been allowed to fly apart, separated by as much distance as the experiment requires. According to quantum mechanics, before either particle is measured, neither has a definite spin. Each exists in superposition, a smear of possible values. But measure one, and the result of measuring the other is instantaneously determined, regardless of the distance between them. Einstein, Podolsky, and Rosen found this unacceptable. If measuring one particle instantly determines the other's outcome, something must have been carrying that information all along, quietly, locally, inside the particle itself. There had to be, they argued, hidden variables. Properties the particles possessed from the beginning of their separation, properties the quantum mechanical formalism simply hadn't been built to see. The theory was not wrong, they conceded. It was incomplete. For nearly 30 years, this debate remained philosophical, a disagreement about interpretation rather than an empirical question. Then John Bell changed that. Bell, working at CERN in Geneva in 1964, derived what is now called Bell's inequality. His reasoning was exact. If local hidden variables exist, if each particle carries its outcome information quietly from the point of separation, then the statistical correlations between measurement results on the two particles across many experimental runs must satisfy a particular mathematical bound. The inequality gave that bound a number. Bell's theorem showed that quantum mechanics predicts correlations that violate this bound. The two predictions are different, and the difference is measurable. The first practical test came in 1972, when John Clauser and Stuart Friedman, working at the University of California, Berkeley, used pairs of polarization-entangled photons to run the experiment. Their result violated Bell's inequality, clearly. But the experiment contained loopholes, imperfect detector efficiency, and the fact that the polarizer settings were fixed in advance, that allowed a careful skeptic to argue that local hidden variables might still, in principle, explain the result. And so the tests continued. In 1982, Alain Aspect and his team at the Institut d'Optique in Orsay, France, ran a significantly more sophisticated version with polarizer settings that switched randomly during the flight of the photons after they had left their source. This closed the so-called communication loophole, the possibility that the two particles were somehow signaling each other about the settings before they were measured. The violation held. The remaining loopholes, the fair sampling assumption, the locality loophole, the freedom of choice loophole, were each addressed in subsequent decades, and each time the violation stood. In 2015, 3 independent groups closed all significant loopholes simultaneously. One group worked at Delft in the Netherlands using electrons in diamond separated by 1.3 kilometers. Another worked in Vienna. A third at the National Institute of Standards and Technology in Boulder, Colorado. All 3 found the same result. The violation of Bell's inequality is real. It is robust. It does not go away. In 2022, the Nobel Prize in Physics was awarded to Aspect, Clauser, and to Anton Zeilinger, who led the Vienna group and whose subsequent cosmic Bell tests, using the ancient light of distant quasars to set the polarizer orientations, pushed the loophole-free threshold back billions of years into the past. The Nobel citation was explicit. The work had proven that nature violates local realism, not suggested it, not made it more plausible, proven it. So what does this actually mean? The universe cannot be simultaneously local, meaning that distant events have no instantaneous effect on each other, and real, meaning that physical properties exist independently of measurement. One of those must go. And the experiments across 5 decades of refinement have converged on which one. Reality is not local, or it is not real in the classical sense, or both. The structure of entanglement, made mathematically precise, is not a mystery of correlation. It is stranger than correlation. 2 correlated things can be correlated because they share a common cause. One sock was packed red, the other blue, and finding one tells you about the other without any mystery. This is not that. In an entangled pair, the full quantum state of the whole system is completely specified. The joint wave function is known exactly. And yet neither particle, considered alone, has a definite state. The mathematics is explicit on this point. The individual particle states do not exist prior to measurement. They are not hidden. They are not merely unknown. They are absent. Until measurement, the individual properties are not waiting to be discovered. They are genuinely not there. and then measurement produces one. The information content of the whole exceeds the sum of the information content of the parts. This is not a loose observation. It is mathematically exact. The parts, separated and considered individually, have no properties to report. The whole has properties the parts do not possess. Non-separability is what this is called, and it is not an interpretation of quantum mechanics. It is what every viable interpretation must account for. Whatever the measurement process turns out to be, and whatever the right understanding of the wave function turns out to be, the non-separability is real. The experiments confirmed it. There is something almost vertiginous about what this means, held quietly. At the level of fundamental physics, below the level of atoms, below the level of any solid thing, there exist systems that are genuinely, irreducibly whole. You can separate the parts in space. You cannot separate the properties. The wholeness persists. Let that settle for a moment before the next step. Hold the two structures in the same frame. In the mind, unity that cannot be found among the parts. Divide consciousness, and you hold only smaller wholes. In matter, wholeness that cannot be assigned to the parts. Separate and entangled system, and each part has no independent properties to report. The structural resemblance is not manufactured. It is what the evidence shows in both domains, arrived at by completely different methods. What it means is a different question, and a much harder one, and that question needs at least one more piece of physics before it can be held honestly. The physicist Herbert Froelich was among the first to ask whether the two structures might be mechanically connected, not merely parallel in shape, but actually linked in fact. Froelich, who spent most of his career at the University of Liverpool and who had worked on the theory of superconductivity, turned his attention in 1968 to the question of quantum coherence in biological systems. His proposal was this: living cells, driven far from thermal equilibrium by metabolic processes, might sustain large-scale collective quantum vibrations across many molecules simultaneously. Not in spite of the warmth and chemical noise of the living environment, but in a specific mode that the metabolic energy supply could maintain against thermal disruption. He called these Froelich condensates, by analogy with the Bose-Einstein condensates that form when quantum particles at extremely low temperatures fall into a collective ground state. The hypothesis was speculative. The experimental tools to test it were not yet available. But the theoretical structure it introduced was precise. If biological systems can sustain quantum coherence at physiological temperatures, then the assumption that quantum effects are irrelevant in the warm, wet machinery of living cells is not a proven fact. It is an assumption. And the question it opened was pointed. If quantum coherence can exist in biological tissue, could it exist in the brain in particular? And if it could, would that change what the unity of consciousness requires as a physical explanation? The question sat without a clear answer for 20 years. Then two figures arrived at it from very different directions, and between them produced the most specific proposal in the history of the science of mind. This was the seed. The plant that grew from it would be more controversial and more precise than most summaries of it allow. Roger Penrose, who had mathematically proven the existence of singularities inside black holes alongside Stephen Hawking, turned his attention to consciousness in 1989 with a book called The Emperor's New Mind. The argument Penrose made was not mystical. It was mathematical, and it began in a place no one expected: the theorems of a Czech-Austrian logician named Kurt Gödel, published in 1931. Gödel proved something that shook the foundations of mathematics. He proved that any formal system powerful enough to express ordinary arithmetic must contain true statements that cannot be proved within that system. The system is either inconsistent, capable of proving false things, or incomplete. Gödel's result was devastating to the program of trying to reduce all of mathematics to a finite set of axioms and rules. But its implications for the mind were not obvious until Penrose drew them. Penrose's reading was this: when a human mathematician recognizes the truth of a Gödel sentence, a statement the system cannot prove, that mathematician is doing something no algorithm can do. A Turing machine, any formal computational system, is bound by its rules. It can derive only what is derivable within its given axioms. It cannot step outside and see that a particular statement, which it cannot prove, is nonetheless true. But human mathematical understanding appears to do exactly this. Humans can see the truth of the Gödel sentence, which means human understanding is not algorithmic, not bounded by any fixed set of rules, not, in the technical sense, computational. This argument has been challenged. Some philosophers of mind find it unconvincing, and the debate about whether it holds up is genuine. But Penrose's move from this starting point is what matters here. If the mind is not a Turing machine, then the physics underlying it cannot be ordinary computable physics. Standard quantum mechanics and classical mechanics and all ordinary physical laws produce only computable processes. If the mind does something genuinely non-computable, then there must be a physical process behind it that is also non-computable. And the only candidate Penrose could identify in known physics, or in the physics waiting to be known, was a process in the regime of quantum gravity. Specifically, in what happens when a quantum superposition becomes large enough to involve a significant difference in space-time curvature between its branches. The idea was this: ordinary quantum superpositions persist until an interaction forces a definite outcome, whatever that interaction turns out to be. But Penrose proposed a different mechanism. Gravity does not fit neatly into quantum mechanics. Unifying them remains one of the central unsolved problems of physics. In the absence of a full theory of quantum gravity, Penrose argued that there is a natural physical scale at which superpositions become gravitationally unstable. When the two branches of a superposition involve mass displacements large enough to produce a measurable difference in space-time curvature, the superposition is physically untenable. It cannot persist. It reduces spontaneously to one outcome. And this reduction, this objective reduction, is governed not by computable rules, but by what Penrose called the correct quantum gravity theory, which he believed would involve non-computable mathematics at its foundation. Objective reduction, then, is the physical process, non-computable, gravitationally triggered, happening when the superposition reaches a mass displacement threshold that Penrose calculated in terms of the Planck mass. For particles on the scale of individual atoms or electrons, this threshold is never reached. They decohere through ordinary environmental interactions long before. But in principle, for sufficiently massive and well-isolated quantum superpositions, objective reduction could occur on timescales relevant to biology. The question Penrose could not answer in 1989 was, where in the brain would this happen? The brain is full of quantum systems, but most of them, the electrons in individual molecules, the ions in solution, decohere through thermal noise on timescales so short they cannot possibly matter for neural processing. He needed a candidate structure that might maintain quantum coherence, in something like the right conditions, long enough for objective reduction to occur at a timescale the nervous system could use. Stuart Hameroff provided it. Hameroff, an anesthesiologist at the University of Arizona, had spent years puzzled by an observation that no one had satisfactorily explained. General anesthetics, which are chemically diverse and seemingly unrelated, all suppress consciousness. And they all interact with the protein assemblies called microtubules, the structural scaffolding of the cell, present in neurons in extraordinary numbers. Hameroff suspected that microtubules were involved in consciousness not just as structural elements, but as quantum computational devices. Their internal geometry, a lattice of protein subunits, each capable of switching between two conformational states, made them, on his analysis, plausible candidates for quantum information processing. When Penrose and Hameroff met in 1992 and compared notes, the pieces fit. The theory they developed together, orchestrated objective reduction, or ORCH-OR, proposes that quantum superpositions exist within the tubulin proteins that make up microtubules, that these superpositions are protected from rapid decoherence by the specific geometry and environment of the microtubule interior, that they are orchestrated by synaptic inputs and other biological signals into coherent states spanning large networks of neurons, and that when the superposition reaches the gravitational threshold, Penrose specified, it undergoes objective reduction, a moment of non-computable collapse that is, on this view, the physical substrate of a discrete conscious moment. Repeat this process at a rate of tens to hundreds per second, and you have the continuous stream of consciousness built from discrete moments of irreducible unity. This is not the cartoonish quantum consciousness of popular misrepresentation. It is a specific, detailed, contested, and not yet refuted proposal in serious physics and biology. Its fate depends on experimental questions that have only partially been answered, but it is the most complete attempt in the history of science to ground the unity of experience in the irreducibility of matter. Before the foundation deepens, one rival must be acknowledged, not dismissed, but placed precisely. The Italian neuroscientist Giulio Tononi at the University of Wisconsin has proposed a theory of consciousness that arrives at the same destination by a completely different route. Integrated information theory holds that consciousness simply is a particular kind of mathematical structure. Specifically, the structure of systems whose causal architecture is irreducible. A conscious system is one in which the integrated information of the whole exceeds the sum of the information in any partition of its parts. Tononi measures this with a quantity he calls phi. When phi is greater than 0, there is experience. The value of phi determines how much. The theory predicts that certain simple systems, a single photodiode for instance, have a tiny but non-zero experience, and that human consciousness corresponds to an extremely high value of phi arising from the particular integrative architecture of the brain's thalamocortical system. The crucial point is this: integrated information theory is not a quantum theory. Phi can in principle be realized in silicon, in a biological network, in any system with the right causal structure. The theory locates indivisibility not in quantum mechanics, but in the mathematics of information. And it arrives at the same structural conclusion, that a conscious system is one that cannot be partitioned without loss, by a path that has nothing to do with Schrödinger equations or objective reduction. This sets up the deepest question clearly. The unity of consciousness is indivisible. Quantum entanglement is non-separable. These are, at minimum, two cases of the same structural type: wholeness that cannot be recovered from parts. Whether the connection between them is mechanical, whether the mind's indivisibility is literally built from the quantum's non-separability, or whether it is only structural, two independent instances of the same mathematical shape, is precisely what is not yet known. Both possibilities are serious. Both are unresolved. What the Foundation has established is this: the binding problem is real and not closed. The measurement problem is real and not closed. The proposal that the two are mechanically connected through quantum processes operating in the biological machinery of the brain is specific, contested, and not refuted. The rival framework that achieves the same structural conclusion through information theory rather than quantum mechanics is also alive and also unrefuted. Two independent proposals, arriving at the same shape by different routes, each finding that a conscious system is one that cannot be partitioned without remainder. And beneath all of these, beneath the OR debate, beneath the IIT mathematics, beneath the decades of Bell tests and decoherence calculations, is the same structural wall, unity that cannot be assembled from parts, appearing in careful investigation of both mind and matter, confirmed in matter by the most rigorous experiments in the history of science, unresolved in mind by any theory available. This is what the science actually says. Not that consciousness and the quantum are the same thing. Not that the mystery is explained or closed, but that the mystery in physics and the mystery in the science of mind share a structure, and that this sharing is not accidental and not yet understood, and has not been wished away by the theories that have tried to explain it. There are anomalies within this picture. There are places where the standard story does not hold, experiments that went somewhere unexpected, calculations that produced the wrong number, biological systems that did something quantum mechanics said they should not be able to do. These are not marginal footnotes. They are the places where the foundation cracks open and something deeper becomes visible. The anomalies do not resolve when pressed. They deepen. The first anomaly is a calculation, not an experiment, not a paradox in logic. A calculation published in 2000 by the physicist Max Tegmark at the Institute for Advanced Study in Princeton. Tegmark wanted to know whether the quantum processes inside the brain, specifically the quantum superpositions that Penrose and Hameroff had proposed as the substrate of consciousness, could possibly survive long enough to matter. He took the numbers seriously. He applied the known physics of decoherence to the specific environment of a neuron. The result was not ambiguous. Quantum coherence in the microtubule-tubulin proteins, Tegmark calculated, would survive for approximately 10 to the minus 13 seconds, a tenth of a trillionth of a second, before thermal noise in the warm, wet, ion-rich cellular environment destroyed it. The timescale relevant to neural processing is measured in milliseconds, thousandths of a second. The gap between the two is 10 orders of magnitude, 10 billion times too fast to matter. The calculation was devastating, or appeared to be. Tegmark was not hostile to the question of consciousness. He was applying standard physics carefully, and the result seemed clear. The brain is simply too hot, too wet, and too noisy to sustain the kind of quantum coherence that OR requires. The same thermal environment that makes biological systems viable also destroys quantum effects almost instantaneously. And if the coherence collapses before it can influence anything at the neural scale, then the entire architecture of OR, the orchestration, the objective reduction, the non-computable moment of experience, has no physical foothold. For several years, this felt like a conclusion. It was not a conclusion, and the reason it was not a conclusion came from an unexpected place, not from a defense of OR, but from a completely separate branch of biology, from a study of photosynthesis. In 2007, Graham Fleming's group at the University of California, Berkeley, and simultaneously Gregory Engel and colleagues working with the same team published results from a study of light harvesting in the Fenner-Matthews-Olson complex. The FMO complex is a protein structure in green sulfur bacteria that captures photons and transfers their excitation energy to a reaction center with extraordinary efficiency. Nearly perfect efficiency. Close enough to perfect that for decades biologists suspected the transfer was happening by some mechanism that classical chemistry could not account for. What Fleming's group found, using ultra-fast spectroscopy techniques that had only recently become available, was evidence of quantum coherence in the transfer process. The excitation was not hopping from one molecule to the next by random classical diffusion. It appeared to be spreading as a quantum wave across multiple pathways simultaneously, sampling all routes at once, finding the optimal path by a mechanism that requires quantum superposition. Coherence signatures were visible at physiological temperatures in a warm, wet biological environment, lasting for hundreds of femtoseconds. Far longer than the naive application of decoherence theory would predict. This result needs to be held carefully. It has been contested. Subsequent work has questioned whether the coherence observed was functional, genuinely contributing to the efficiency of the transfer, or merely vibrational, a quantum wobble in the molecular dynamics that happened to produce coherence-like signals without actually routing the excitation quantumly. The debate is ongoing. The result has not been cleanly confirmed as functional, and it has not been cleanly dismissed. The honest position is, warm, wet biology can sustain quantum coherence in some contexts. Whether this is happening in ways that matter to the function of those systems is not yet established. But the door that Tegmark's calculations seem to close is open again, not flung wide, open. And around the same time that the photosynthesis results were appearing, another set of experiments was producing something equally strange from a completely different direction. Birds navigate. This is unremarkable. What is remarkable is how some of them do it. The European robin, Erythicus rubecula, migrates thousands of kilometers with a precision that ordinary magnetic field sensing cannot explain. The field is too weak, and the bird's sensory organs too small, for the classical mechanisms of magnetic navigation to account for the accuracy. Klaus Schulten, a theoretical chemist at the University of Illinois, had proposed as early as 1978 that the mechanism might be quantum, specifically that a molecule called cryptochrome, found in the bird's eye, undergoes a light-induced reaction that produces a pair of electrons in an entangled quantum state, a state called a radical pair. The magnetic field of the Earth subtly influences the evolution of this entangled state. The bird, in some sense, reads the Earth's magnetic field through the quantum spin correlations of entangled electrons in its retina. This too has been contested, refined, and extended. The evidence for the radical pair mechanism in avian magnetoreception is now substantial, though the full picture is still being assembled. What matters here is the structural point. Nature appears to have found ways to exploit quantum effects, including entanglement-like correlations, in warm biological systems for functional purposes over timescales long enough to influence behavior. The assumption that the biological world is simply too noisy for quantum mechanics to matter is not as solid as it appeared after Tegmark's calculation. So the question remains genuinely open. Whether the brain, specifically, exploits quantum coherence in ways relevant to consciousness is not known. What has changed is the prior probability assigned to that possibility. It is not negligible. Sit with the uncertainty for a moment. The mind wants resolution here. It wants the question closed in one direction or the other. What the evidence provides is something more uncomfortable, a space of genuine not knowing, bounded on one side by a calculation that gave a devastating number, and on the other by a biology that turned out to be more quantum capable than anyone expected. The question is alive. The answer is not in. And this is not even the deepest problem. The deepest problem concerns what is happening when a measurement occurs, not in the brain, but anywhere. The measurement problem was named in Movement 2, but its full strangeness requires a closer look, because physics has not ignored this problem. Physics has generated multiple proposals for how to handle it. None of them has achieved consensus. And the disagreement is not merely technical. It is about what the physical world fundamentally is. The first and oldest response is what is called the Copenhagen interpretation, the working framework adopted by Niels Bohr, Werner Heisenberg, and most of the founders of quantum mechanics in the 1920s. Copenhagen says, in its cleanest form, the wave function is a tool for predicting measurement outcomes. It is not a description of what is really happening between measurements. The question, what is the electron doing before it is measured, is not a meaningful physical question. Only measurement results are real. The rest is calculation. This is not a fringe view. It remains the dominant pragmatic stance among working physicists. It produces the right experimental predictions every time, but it purchases its clarity at a price. It refuses to say what the physical world is actually like when no one is measuring it. The wave function describes our knowledge of the system, not the system itself. Reality, in the Copenhagen framework, is what shows up on a detector. What is behind the detector is, strictly speaking, not a question physics answers. Many physicists find this deeply unsatisfying, and the most ambitious attempt to do better was Hugh Everett's. In 1957, Hugh Everett, a graduate student at Princeton who would spend the rest of his short life in defense consulting, proposed that the wave function never collapses. Ever. The smooth Schrödinger evolution is all there is. When a measurement occurs, what happens is not that one outcome is selected and the others discarded. What happens is that the universe branches. All outcomes occur, each in its own branch of the universal wave function. The observer also branches, with one copy of the observer in each branch, each copy seeing a different outcome and having no knowledge of the others. This is the many worlds interpretation, as it came to be called. Many worlds is internally consistent. It requires no additional postulate beyond the Schrödinger equation. It produces the correct experimental predictions, and it implies that every quantum event that could have gone differently has gone differently. In a vast branching structure of parallel histories, each as real as this one. The honest position about many worlds is this: no one has found an internal contradiction in it, and no one has found a way to test whether the branches are real. The theory is empirically equivalent to every other viable interpretation. They all predict the same measurement outcomes. What differs is the ontology. What kind of thing the theory says the world is. And on that question, the measurement problem remains open. Many worlds does not solve the measurement problem by explaining collapse. It dissolves it by denying that collapse occurs. Whether that is an explanation or an evasion depends on what you think an explanation is supposed to do. Two other frameworks are worth naming. The objective collapse theories, of which the most mathematically developed is the GRW model proposed by Gherardi, Rimini, and Weber in 1986. Add a physical mechanism to the standard quantum formalism that produces spontaneous probabilistic collapses of the wave function at random times. The rate of collapse is calibrated so that for small systems, the effect is negligible, but for large systems, large enough to include measuring devices and human observers, the collapses happen so frequently that the system is always effectively classical. The theory is testable. In principle, it predicts tiny deviations from standard quantum mechanics that might be detectable with sufficiently sensitive experiments. So far, no such deviations have been found. The GRW model is alive. It is not confirmed. And then there is cubism, quantum Bayesianism, proposed around 2010 by the physicist Christopher Fuchs and the philosopher Norman David Mermin. Cubism takes the Copenhagen idea and makes it more radical and more honest at the same time. The wave function in cubism is not a description of a quantum system. It is not even a description of our collective knowledge about the system. It is the belief state of a single agent, a single conscious user of quantum mechanics, encoding that agent's personal expectations about the outcomes of their own future experiences. Quantum mechanics, on this reading, is a tool for navigating experience, not a map of the world. The world, as it is in itself, is simply not what quantum mechanics is about. Cubism does something unusual. It puts the subject, the agent, the experiencer, explicitly back into the foundations of physics without making consciousness the cause of physical events. The agent is not collapsing waves. The agent is using a calculus that is always relative to an agent's experience. The measurement problem, in cubism, is not a problem about what happens in the world. It is a feature of the first-person structure of the theory. No interpretation has achieved consensus. This is the honest position, not because the physicists have not tried hard enough, because the question of what quantum mechanics says reality is, below the level of measurement outcomes, is genuinely, stubbornly open. The mathematics works perfectly. The reality it describes is in dispute. And this is where the specific question of consciousness becomes strange in a new way. Recall the combination problem. If consciousness is fundamental, if experience is not manufactured by brain processes, but is in some form present at the base of nature, then the question is not only how a unified experience arises from a unified physical system. The question is how countless small experiences, the putative micro-experience of every particle, every quantum event, every interaction, could possibly combine into the single, unified field of a conscious mind. This problem was named by the philosopher William Seeger in 1995, and it is not a minor technical refinement. It is the same wall, wearing a new face. You cannot assemble unity from distributed experience any more than you can assemble unity from distributed neurons. Every proposed solution to the binding problem in neuroscience encounters an analog in the combination problem in philosophy of mind. The unity resists composition. Always. Some thinkers have concluded that the only way out is to refuse the premise. The German-Australian philosopher Bernardo Kastrup, writing in the first decades of this century, proposed that the combination problem dissolves if consciousness is not built from small pieces at all. If, instead, a single field of awareness is primary, and the appearance of many separate minds is what requires explanation. His model, which he calls analytic idealism, draws on the clinical observation of dissociative identity disorder, a single underlying system from which multiple relatively autonomous subsystems can emerge, each with bounded awareness, while the underlying unity persists. The mechanism matters here, because this is not the pop spiritual version of "we are all one." Kastrup is making a specific structural argument, not a feeling of cosmic unity. In dissociative identity, one person is present. Multiple alters, relatively autonomous clusters of personality and memory, operate with partial independence. They do not know each other's content fully. They can disagree, be unaware of each other's actions, have different values and responses. And yet there is one body, one nervous system, one underlying substrate. The unity is not experienced from inside any single altar. It is the ground from which the altars arise. Kastrup's proposal is that the brain, on the idealist model, is not generating consciousness from electrochemical activity. The brain is, from the third-person, outside perspective, what one particular region of bounded self-excitation within a universal field of awareness looks like. The boundary produces the appearance of an individual. The individuality is real within the boundary. The unity is real beneath it. The combination problem on this model does not need to be solved. It needs to be dissolved by recognizing that the unity was never lost. The many is what requires explanation, not the one. This is not presented as a conclusion. It is a serious philosophical proposal that takes the hard problem and the combination problem seriously enough to follow their logic to an uncomfortable destination. Its discomfort is part of what recommends it. A framework that resolved these problems comfortably would be suspicious. The honest versions of difficult questions tend to be uncomfortable. What is established is this. Physics has proven that nature contains genuine, irreducible, non-separability at the quantum level. This is not in dispute. What is unproven is whether the brain exploits this non-separability in ways that matter to consciousness. What is unsolved is the measurement problem. The question of what physically happens when a quantum superposition becomes a definite outcome, and it has been unsolved for 90 years. What is unsolved is the hard problem. What is unsolved is the combination problem. These are not failures of nerve or intelligence. They are the genuine limits of what the current frameworks can reach. But there is one more physicist who belongs in this accounting. One more figure who took the openness seriously and followed it somewhere most of his colleagues refused to go. John Wheeler named the black hole. He also named the wormhole. He spent decades at the center of American theoretical physics, at Princeton, then at the University of Texas. And by the time of his later years, he had become convinced of something he found impossible to dismiss. That information is not a secondary property of the physical world. That information is what the physical world is made of. He called it from bit. The proposal, developed through the 1980s and 90s, is that every physical entity, every particle, every field, every structure in space-time derives its existence from answers to yes or no questions. Binary choices, bits, in the language of information theory. The universe, on this view, is not a collection of things that carry information. It is a structure of information from which the appearance of things emerges, beneath matter, beneath space, beneath time, information, and the act of registering an answer, what physics calls measurement, what observation theory calls interaction, is what brings the facts of the world into being. Wheeler was precise about what this did and did not mean. He called the resulting picture the participatory universe. But he was careful, more careful than the people who have since popularized his phrase, not to say that conscious minds are required to make the world real. An elementary particle interaction in a star billions of light years away registers an answer. It brings a bit of fact into being. The universe participates in its own constitution. The participation does not require persons. It requires, in the minimal sense, registration, interaction, the physical act of one system leaving a mark on another. And yet the measurement problem hangs over all of this, because even if information is fundamental, The question of why one particular answer is registered, why this outcome and not that one, remains open. The participatory universe does not close the measurement problem. It reframes it. Wheeler tested part of his view with a thought experiment that became an actual experiment. He proposed in 1978 what he called the delayed choice experiment, a version of the double-slit setup in which the decision of whether to observe which path the photon took is made after the photon has already passed through the slits. The experiment was technically demanding, and it was not until 2007 that Vincent Jacques and colleagues working in Paris realized it in a clean form. The result was what Wheeler predicted. The photon's behavior, wave-like or particle-like, was determined by the choice made after the fact, as if the present act of observation were reaching backward in time to select the nature of the past event. This is not time travel. It is not retrocausation in any straightforward sense. It is the quantum formalism doing what it always does, producing correlations between measurement settings and outcomes that cannot be explained by classical local hidden variables. But the structure of the result is genuinely strange. The observable behavior of the photon's past is, in a precise sense, set by what is decided about it now. The honest position here is the same as everywhere else in this territory. The experiment has been done, the result is clean, and the interpretation is contested. Many worlds gives one reading. All outcomes occurred, and the observer's choice determines which branch they find themselves in. Copenhagen gives another. The wave function is a predictive tool, and it is not meaningful to ask what the photon was doing before the measurement was made. Cubism gives a third. The past, as represented in the wave function, is an agent's belief state, and updating that belief state at any point, including after the event, is legitimate. The structure of the result is agreed. What it means about time, causation, and the role of registration in bringing facts into being is not settled. What Wheeler contributed to this inquiry is a specific and serious proposal: that the universe is, at its foundation, made of participatory facts, not independently existing things, and that the boundaries between observer and observed, at the quantum level, are not sharp. Not because the observer is creating reality with their wishes, but because the structure of physical reality, as the equations describe it, requires interaction to be definite. Isolation in quantum mechanics is superposition. Only relation produces fact. Take a moment here. That is a strange sentence. Isolation is superposition. Only relation produces fact. It is worth letting it settle rather than moving past it too quickly. This is not the warm, reassuring version of quantum connectedness. It is something more demanding than that. It is the mathematics saying that definite properties do not belong to systems in isolation. They belong to systems in interaction. The definiteness of the world is relational, always. The isolated, self-contained, independently real thing is a limit case that quantum mechanics does not permit at the fundamental level. The world is not made of things with properties. It is made of relations that produce properties. And this, the relational nature of definiteness, connects back to the combination problem through a door that is easy to miss. Recall the structure. The binding problem says that unified experience cannot be assembled from distributed neural processes. The combination problem says that unified experience cannot be assembled from distributed micro-experiences, even if consciousness is fundamental. Every assembling move fails. Unity resists composition. But the same pattern appears in quantum non-separability. An entangled system's properties cannot be assembled from the properties of its parts. because the parts, considered separately, do not have the properties. The whole has properties the parts, by themselves, simply lack. The information is in the relation, not in the components. The wholeness is not built, it is primitive. 3 times, in 3 separate investigations, in the neuroscience of binding, in the philosophy of mind's combination problem, and in the quantum mechanics of entangled systems, the same structural fact appears. You cannot assemble unity from parts. Unity, when it appears, is not constructed. It is found. It is prior to the division. The separation is what requires explanation, not the wholeness. This is the deepest convergence in the picture that physics has assembled. It is not the convergence of answers. It is the convergence of a single irreducible structure of the question. From 3 different starting points, using 3 different methods, the investigation arrives at the same wall. What is on the other side of that wall is what physics cannot say. Not because physics is failing, because the question of what is on the other side of that wall may require a different kind of investigation than physics is equipped to conduct. Physics is an investigation of the third-person structure of the world, of what shows up when one system interacts with another, when measurement registers an outcome, when a detector fires and a number is recorded. It has been breathtakingly, vertiginously successful at this kind of investigation. The success is not in question. What is in question is whether the third-person investigation can, in principle, be completed, whether it can account for the first-person fact of experience, or whether the first person is a domain that requires a different method. There are those who have spent lifetimes developing that method, not as a spiritual comfort, not as a set of beliefs about reality, as a rigorous, demanding, painstaking investigation of the structure of awareness itself, conducted from the inside. Their results are not equations. They are accounts, sometimes texts, sometimes transmissions passed by mouth from teacher to student across centuries, of what awareness looks like when it is examined with the same care and precision that physics applies to what awareness encounters. The records are old. The structure they describe is not. Their languages are different. Their methods differ entirely. The structure they describe is the same. The investigation that is about to begin is not the same kind of investigation as what preceded it. It does not use detectors. It does not produce equations. It is conducted in silence over decades by individuals whose discipline is not the rigorous control of external conditions, but the rigorous control of attention itself. Its results cannot be submitted to a journal. They cannot be replicated by anyone who has not undergone the preparation the investigation requires. These are not deficiencies. They are descriptions. What is being investigated is not an external system. It is the instrument of investigation itself. The question is not what awareness encounters. The question is what awareness is. When that question is pressed directly, and the ordinary evasions are refused. The evasions in this investigation take a specific form. The ordinary mind, busy, commentary producing, restless, always reaching toward the next thought, tends, when asked to examine itself, to examine its content rather than its nature. It looks at the thoughts, not at what is aware of the thoughts. The discipline of the contemplative traditions is, in its most stripped-down form, the repeated refusal to mistake the contents of awareness for awareness itself. That discipline, sustained for years, is reported to produce something specific, not a new experience, but a recognition of what was always present beneath all experience, not an achievement, but a discovery that the thing being searched for was never absent. This is the claim. It should be held with the same care that is applied to the claims of physics, neither dismissed because it is unfamiliar, nor accepted because it is beautiful. What follows is what the traditions actually say, not the popular version, not the feel-good version, but the technical and often demanding content that lineage holders transmit and that most accounts of these traditions quietly omit. The first and deepest point of structural resonance comes from the Indian subcontinent, from a text that is over 3,000 years old and is still widely misread. The Chandogya Upanishad contains a teaching given by the sage Uddalaka Aruni to his son Shvetaketu across 9 consecutive lessons, preserved in the 6th chapter of the text. Shvetaketu has returned from 12 years of Vedic study, confident in his learning, and, his father judges, a little proud. Uddalaka begins to dismantle that confidence with a series of examples drawn not from scripture, but from nature. He takes a lump of salt and dissolves it in water, asks Shvetaketu to find the salt the next morning. The son reaches into the water, then another place, then another. Salt everywhere but nowhere visible. The water tastes of it throughout. The salt has not disappeared, it has permeated. Then Uddalaka speaks the sentence that has been repeating through Indian philosophy ever since. You are that, tat tavam asi. The popular reading of this sentence is almost universally wrong, and the wrongness matters. The popular reading hears it as an identity statement. You, the individual self, are identical with the Absolute, with universal consciousness, with God or Brahman. The hearing produces a warm, expansive feeling. The individual dissolves into the cosmos. All is one. This feeling is real. The teaching it is being attributed to is not what Uddalaka said. What Uddalaka is demonstrating across 9 examples is not identity, but something more precise and considerably more demanding. He is pointing at what the Advaita Vedanta philosopher Shankara, working in the 8th century and constructing the most rigorous commentary on these teachings in the history of Indian philosophy, called the distinction between what is apparent and what is real. Brahman, the ground of being, is not a substance that the individual self merges into. It is what remains when the process of mistaking appears to be separate things for actually separate things is examined all the way down. The salt does not merge with the water. The salt was already in the water. The apparent separation was not a union that needed to happen. It was an appearance that needed to be seen through. The technical machinery Shankara applies to this distinction is sophisticated and often suppressed in popular accounts. He works with 3 levels of reality: the apparent world of ordinary waking experience, which is not unreal, but is like a dream in that it depends entirely on something else; the conventional reality of objects and persons, which operates consistently but conceals its own dependence; and the absolute, which is what is, undivided, beyond characterization, neither a thing nor a non-thing. The relationship between these 3 levels is not merger. It is recognition, the recognition that the apparent plurality was never the full story of what is. The structural parallel to what physics encountered in Movement 3 is not incidental. It is the same shape. Wheeler's participatory universe proposes that definite properties do not belong to isolated systems. They belong to systems in relation. Isolation is superposition. Only interaction produces fact. Shankara's analysis proposes that apparent separation does not belong to the nature of what is. It belongs to the way in which what is appears when examined from inside a particular conditional perspective. Remove the conditionality, and the separation turns out to have been the surface, not the depth. The languages are entirely different. The methods could not be more different. One is algebra and laboratory apparatus. The other is sustained attention and the precision of a lineage trained over centuries. The structural pattern is the same. Apparent separation as the surface of an underlying wholeness that the surface does not negate, but conceals. The Mandukya Upanishad, the shortest of the principal Upanishads, 12 verses, goes further than the Chandogya in a direction that most readers miss entirely. It distinguishes 4 states of consciousness: waking, dreaming, deep dreamless sleep, and a fourth, turiya, a Sanskrit word that means simply the fourth. The popular reading of turiya is that it is a special state of consciousness that meditators achieve by going beyond the other 3. It is something to attain, an elevated condition. This is the misreading. What the text actually says, and what the Advaita tradition transmits through its lineage, is that turiya is not a state at all in the ordinary sense. The other 3, waking, dreaming, deep sleep, arise and pass away. Turiya does not arise. It does not pass away. It is the ground in which the other 3 appear, not a fourth thing alongside the other 3. The awareness that never ceases, never moves, never becomes other than what it is, in which waking and dreaming and deep sleep come and go like weather. It is the indivisible substrate, not achieved, not produced, not assembled, that the other states rest on without exhausting it. The parallel to quantum non-separability is structural and specific. In entanglement, the whole state is fully specified, completely real, while the individual parts have no independent state to specify. The wholeness is primitive. The apparent independence of the parts is what requires an account. In the Mandukya's teaching on turiya, the undivided awareness is primitive, always present, never absent, while the apparent succession of states is what requires an account. The parts are real, but they are not separable from the ground. The separation is how things appear from inside a state, not how they are in the structure that contains all states. Physics did not confirm this. The Upanishad did not predict it. The convergence is architectural. Both are descriptions of the same structural fact using entirely different languages and entirely different methods. What the Yogacara school of Buddhist philosophy developed, 4 centuries after the principal Upanishads were composed, is a structural analysis of experience that arrives at the same wall from a different direction, and illuminates something about the mechanism that most popular accounts of consciousness theory completely miss. Asanga, who worked in northwest India in the 4th century, and his younger brother Vasubandhu, whose systematizations became the foundation of Yogacara philosophy, proposed a theory of consciousness that does not begin with the unity of experience and ask how it is produced. It begins with the appearance of a subject-object split, the felt sense that there is a knower over here and a world over there, and asks what it would take for that split to be constructed rather than given. What Yogacara proposes is this. Beneath the 6 familiar modes of cognition, sight, sound, smell, taste, touch, and discursive thought, there are 2 additional levels of consciousness. The 7th is what the tradition calls afflicted mind, the constant background sense of there being a separate self, a grasper at the center of experience. And the 8th, the substrate consciousness, or alaya vijnana, is the ground beneath even that. The cartoon version of alaya vijnana, which appears in pop Buddhism books, calls it a storehouse consciousness, a mental warehouse where the seeds of past actions are accumulated and from which future experiences grow. This is a simplified translation of one function the tradition attributes to it. The actual operative claim, which the lineage teaches and which Vasubandhu's own works make explicit, is something more precise and more disturbing. The alaya vijnana is not a storehouse. It is the stream, the continuous, unbroken, flowing substratum beneath the arising and passing of all other mental events. And the seventh consciousness, the afflicted mind, the grasper, makes a specific mistake about it. It takes this flowing substratum and misidentifies it as a self. It grasps the stream as a thing, a fixed, bounded, independent entity at the center of experience. And out of this misidentification, the apparent split between subject and object, between grasper and grasped, grahaka and grahya, is constructed, not given, not fundamental, constructed, moment by moment, from the root confusion of mistaking the stream for a self. The structural parallel to decoherence theory is almost uncannily precise. Decoherence theory explains how quantum superpositions, the underlying non-separable wholeness, appear classical to an observer embedded within them. The entanglement between system and environment produces the stable illusion of definiteness and separateness at the level of experience, while the underlying non-separability remains intact beneath that appearance. The classical world is built over the quantum world by the mechanism of interaction, real, stable, consistent, and entirely dependent on what is beneath it. In Yogacara, the constructed subject-object split is built over the flowing substratum of the alaya vijnana by the mechanism of misidentification, real, stable, consistent, and entirely dependent on what is beneath it. The apparent duality is not false. It is the surface. The surface is constructed. The construction is stable. And beneath it, the ground is undivided. The languages are different. The methods differ. The architecture is the same. Before the Tibetan tradition enters, there is an older set of investigations that must be acknowledged, older even than the Upanishads in some forms, though the texts that carry them are a few centuries younger than the oldest Vedic hymns. The Tao Te Ching, attributed to Laozi and composed in China during the 6th or 5th century before the Common Era, is the most translated book in history after the Bible. It has also been consistently misread in two opposite directions for 2,000 years. One reading makes it a manual of political quietism. The sage rules by not ruling, the ruler governs by yielding. Another reading makes it a mystical celebration of natural harmony. Go with the flow, trust the universe, align with the gentle power of water. Both readings exist because the text permits them. Both readings miss what the text is doing at the technical level. The commentary tradition reveals this. The two most important classical commentaries on the Tao Te Ching, both produced during the 3rd century of the Common Era, arrive at such different readings of the same text that they effectively describe two different books. Wang Bi, who wrote his commentary around 240 CE at the age of roughly 20, reads the Tao as the ultimate principle of reality, the ground that cannot be named, the source from which all things emerge without any of the things being able to describe it. For Wang Bi, the famous opening line, "The Tao that can be spoken is not the eternal Tao," is a statement about the limits of language and conceptual thought when applied to what is most fundamental. The Tao, on Wang Bi's reading, is the structural ground of being. It is not a thing. It is not a process. It is what makes things and processes possible without itself being either. The Hexiang commentary, produced in roughly the same period, reads the text entirely differently. For Hexiang, the Tao is not an ontological ground, but a cosmological force, a flow that the individual practitioner can align with through breath practice and meditative cultivation. The Tao, on this reading is something you can participate in, something that can be cultivated in the body, something that sustains life when worked with and depletes it when resisted. These are not minor variations. They produce different practices, different metaphysics, and different pictures of what the text is pointing at. And the divergence is not resolved by reading the text more carefully. The text is genuinely ambiguous between them. What both commentaries agree on, and what neither popular reading captures, is that the Tao is prior to distinction. The famous passage in chapter 1. The named is the mother of 10,000 things. The nameless is the mother of heaven and earth. This is not a statement about language. It is a claim about ontological priority. What is prior to distinction, what the tradition calls the uncarved block pu, is not an undifferentiated mush. It is the condition of possibility for all differentiation, which contains differentiation without being differentiated. The 10,000 things are real. Their distinctness is real. And that distinctness arises from and within something that is prior to it, that is not itself distinct from anything, and that does not negate the distinctions, but grounds them. The structural parallel to quantum mechanics is not the popular one, not flow like water as a metaphor for uncertainty, but something more precise. The Tao, as prior to distinction, parallels the quantum ground state as prior to definite properties. In quantum mechanics, the ground state of a system, the state of minimum excitation, is not a state in which all properties are zero. It is a state in which the properties that classical physics would assign to the system are not yet defined. The zero-point fluctuations of the vacuum, the ground state of the quantum field, are not empty, but seething with the virtual activity of a structure that is, in some sense, prior to the distinction between particle and no particle, between something and nothing. Measurement, interaction, produces specific facts from this prior state. Without measurement, the prior state is not nothing. It is the ground. The Tao and the quantum vacuum are not the same concept. The methods could not be more different. The structural shape, a ground prior to distinction from which definite things arise through interaction, is architecturally the same. Now, the most important demolition in this script, and the most common misreading of the non-dual contemplative traditions. It is often said, in books, in courses, in social media productions of various kinds, that the teaching of these traditions is that we are all one consciousness, that your mind and my mind and the tree's mind and the universe's mind are all the same mind. That separateness is an illusion that can be dispelled by spiritual practice, and that recognizing our unity means experiencing a dissolution of boundaries and a merger with everything. This version of the teaching produces a particular feeling. The feeling is real. The teaching it is attributed to is not what the traditions transmit. The precise claim of the highest teachings of both Advaita Vedanta and the Tibetan tradition known as Dzogchen is not that many separate things merge into one. It is that the separation was never what it appeared to be. Non-duality, Advaita, not two, is not the fusion of two things. It is the recognition that the two things were never actually separate in the way they appeared to be. This distinction is not semantic. It is the difference between a spiritual technology that aims at producing a feeling of expanded unity, an altered state, pleasant, temporary, dependent on conditions, and a pointing out instruction that reveals what was always already the case regardless of what is being felt. One produces an experience. The other is the recognition of what precedes all experience. The popular version of non-duality fails the traditions on their own terms. The traditions are unanimous on this point. Rigpa cannot be achieved. It cannot be constructed. It cannot be reached by making SEMS more refined or more quiet. The effort to meditate one's way into the non-dual ground is, from the Dzogchen perspective, precisely the activity that keeps the ground concealed, because it presupposes a meditator separate from the ground, reaching toward something other than themselves. The recognition is not the result of effort. It is the cessation of the particular kind of effort that has been maintaining the illusion of separation. And that cessation is not nothing. It is the recognition of what was always present, always whole, always undivided, the single sphere, thigla-nyag-gikig, the indivisible nucleus of awareness that SEMS arose within and never actually left. The structural parallel to the combination problem is exact. The problem, as it stands in philosophy of mind, asks how micro-experiences combine to produce a unified macro-experience. The Dzogchen tradition implies, through an entirely different method and an entirely different language, that this is the wrong question. The unity is not produced. The unity is what is prior. The micro-experiences arise within it. The whole is not assembled from the parts. The parts appear within the whole. The direction of explanation runs opposite to the direction the combination problem assumes. Longchenpa, the 14th century Tibetan scholar and master of the Nyingma school, articulated this in a body of work, particularly the Seven Treasuries and the Trilogy of Natural Ease, that remains among the most precise and technically demanding accounts of the nature of awareness ever written. The distinction Longchenpa draws, with a precision that the lineage has taken centuries to transmit, is between ordinary discursive mind, SEMS in Tibetan, and pure awareness, Rigpa. SEMS is everything the ordinary meditator takes themselves to be, the arising and passing of thoughts, the commentary, the memory, the plan, the reaction, the subtle hum of the observer watching all of this. SEMS is divided, momentary, conditioned. It is what produces the sense of an experience happening to a separate experiencer. Rigpa is something else entirely, and the lineage is precise about this. Rigpa cannot be described, produced, or achieved by any modification of SEMS. It is not a quieter version of ordinary mind. It is not a state that meditative practice builds. It is what is always and already the case. The indivisible awareness within which SEMS arises and passes, which is never itself a SEMS, never itself divided, never itself conditioned. The texts point at it. The lineage transmits it in the pointing out instruction. The actual transmission, given by a qualified teacher to a prepared student, in which Rigpa is directly recognized rather than conceptually understood. The technical term for awareness as indivisible whole in the Dzogchen tradition is the single sphere, thigla-nyag-gcig, one nucleus, not assembled from parts, not produced by conditions, not the result of any practice. The unity is not built. It is what is recognized when the construction of SEMS, the effort to maintain the sense of a separate experiencer, is allowed to release. What remains is not emptiness in the annihilative sense. It is aware. It is present. It is indivisible. The structural parallel to the combination problem in philosophy of mind is exact. The combination problem asks, how do micro-experiences add up to produce a unified macro-experience? The answer the Dzogchen tradition implies, through a completely different method and language, is that they do not. The unity is not produced by combination. The unity is what is already the case, and the appearance of multiplicity is what arises within it, not what produces it. The problem of combination is the wrong problem. It presupposes that the parts are primary. The tradition says the whole is primary. The division requires explanation. The unity does not. And here the Abrahamic traditions enter, from a direction so different that most comparative religion accounts miss the structural depth entirely. Ibn Arabi, the Andalusian master who was born in Murcia in 1165, and who, over the course of his long and prolific life, produced a body of metaphysical writing dense enough to occupy his commentators for the next 8 centuries, proposed something that the Orthodox Islamic tradition spent those same 8 centuries trying either to suppress or to sanitize. He called it the unity of being, wahdat al-wujud. And the popular reading of this phrase is as misleading as the popular reading of tat tvam asi. The popular reading hears wahdat al-wujud as a kind of pantheism. God is everything. Everything is God. The world and the divine are the same thing. Ibn Arabi's actual claim is more precise, and it was the precision that threatened the orthodox tradition. What Ibn Arabi proposes is not that the world is God, but that there is only one being, one act of existence, and that what we call the world and what we call God are not two things that are identical, but the self-disclosure and the disclosure of that single being, related by a structure he spent volumes describing, and which no simple equation captures. The specific structure that most popular accounts omit is the barzakh. This word means, in ordinary Arabic, an isthmus, a narrow strip of land that at once joins and separates 2 seas. In Ibn Arabi's metaphysics, the barzakh is an ontological category, not a spatial one. It is the threshold between the one and the many, the real and the apparent, the disclosure and the self-disclosure, a mode of being that is neither wholly one thing nor wholly the other. Not God and not the world, but the threshold through which being self-discloses into multiplicity without ceasing to be one, not a third thing between 2 things. A structure of relation that is prior to both terms of the relation. This cannot be reduced to a simple statement. Ibn Arabi himself said it cannot be reduced to a simple statement. And the 6 centuries of suppression this teaching received from orthodox Islamic jurisprudence was not irrational. What Ibn Arabi was pointing at was genuinely threatening to the categories that theology requires. The clear distinction between creator and creation, between the real and the apparent, between the infinite and the finite. The barzakh does not deny these distinctions. It shows that they are not what they appear to be, that the threshold between them is a real structure, not a clean line. The structural parallel to the quantum measurement problem is not decorative, it is architectural. The measurement problem asks, where does quantum reality, which permits all possibilities simultaneously, become the classical reality in which one thing is the case? Where is the cut? The answer the physics cannot give is that the cut cannot be located, because the threshold between the quantum and the classical is not a sharp boundary. It is a structure of relation, real, operative, impossible to fully specify in terms of either of the 2 domains it separates. The barzakh and the von Neumann cut are not the same concept. They are not even the same kind of concept. But they point at the same structural fact, that the threshold between the fundamental and the manifest does not resolve into a clean line between them. The map and the territory are not the same, but the maps, drawn from different continents using different instruments over different centuries, describe the same threshold with the same structural difficulty. The final tradition in this account requires a different kind of attention because its structural parallel is the most exact in the entire script. In 643 CE, the Buddhist monk and scholar Fa Zhang who would become the founder of the Huayan school of Chinese Buddhism, was granted an audience with Empress Wu Zetian of the Tang dynasty, who wanted him to explain the central doctrine of his school, the mutual interpenetration of all phenomena. Fazang asked permission to use the palace hall. He led the empress into a room lined with mirrors, mirrors on the walls, on the ceiling, on the floor, and placed a single candle in the center. The candle's flame appeared in every mirror. Each mirror reflected every other mirror, and so each reflection contained all the other reflections, which contained all the other reflections, in an infinite, recursive mutual inclusion. Fazang turned to the empress and said, "This is the nature of reality." The popular account stops there. The jewel net of Indra is beautiful. The image of infinite mutual reflection is evocative. Most accounts of Huayan thought leave it as an image. What the actual philosophical machinery says is more precise. Fazang worked with a framework called the fourfold Dharma Dhatu, 4 modes of reality and their mutual relationships. The first is phenomena considered individually. The second is principle, what the tradition calls li, the underlying ground that phenomena express. The third is the mutual non-obstruction of principle and phenomena. The ground does not negate the particular, and the particular does not obstruct the ground. The fourth, and this is the level most accounts never reach, is the mutual non-obstruction of phenomena with each other, not just each phenomenon with the underlying principle, each phenomenon with every other phenomenon directly, without the mediation of a separate substrate. This fourth level is what the Hall of Mirrors demonstrates. Each jewel in the net contains not just a reflection of the whole net, but a reflection that itself contains reflections that contain reflections, without limit. The containment is not metaphorical, it is ontological. Each phenomenon is, in its nature, constituted by its relations to all other phenomena, so that what any one thing is cannot be fully specified without specifying everything else, and vice versa. The parts are not separable from the whole. They are not even, strictly speaking, parts. They are nodes in a structure of mutual constitution that has no independent elements. The parallel to entanglement and to the holographic principle in quantum information theory is the most structurally precise in this entire account. In an entangled system, the properties of the whole cannot be distributed among the parts. They are irreducibly joint, and every local interrogation of a part already encodes information about the whole. In the holographic principle, which emerges from the study of black holes and has been developed into a precise conjecture about the structure of space-time, all the information contained in a volume of space is encoded in its boundary. The interior is fully described by its surface. Every part encodes the whole. The whole is in the part. This is not a loose analogy. It is the same information-theoretic structure that Fazang's fourfold Dharma Dhatu describes in the language of ontology. The mutual non-obstruction of phenomena is not poetry about interconnection. It is a claim about the structure of information in reality, that the separation between things is not the final word about what things are. The languages are different. The methods differ entirely. The structure is the same. And the same discipline applies here as everywhere in this account. Huayan philosophy did not predict the holographic principle. Quantum information theory did not validate Fazang. These are independent investigations, conducted by independent methods, arriving at the same architectural shape. The shape is real. What it means, what it points at, what ground it describes, remains an open question. All 4 traditions, examined at the depth the lineages transmit, rather than the depth that popular accounts reflect, arrive at the same structural conclusion through completely different routes. The Hindu non-dual traditions find awareness as an undivided ground beneath the apparent plurality of experience. The Yogacara tradition finds the subject-object split as a construction built over an undivided substrate. The Dzogchen tradition finds the single sphere of indivisible awareness as what is recognized when the construction releases. The Sufi tradition finds a threshold, the barzakh, that cannot be located but is real, through which the one and the many relate without resolving into either. And the Huayan tradition finds a structure of mutual inclusion so thorough that no element is separable from any other. These are not the same description. The traditions are distinct. Their methods are incompatible in several ways. Their metaphysical commitments differ in important respects. It is not possible to merge them into one account without violating each of them, but the structural fact they all point at is the same. Unity is not assembled. Separation is not fundamental. The investigation, pressed to its limit from the inside, reaches a ground that the investigation itself cannot be separated from. This is not convergence. It is recognition. And the recognition does not resolve the question. It deepens it into a territory that requires the next thing to be named. What physics has established, what physics has suggested, and what remains, at the edge of both investigations, genuinely and irreducibly open. So what does all of this mean? Not for physics. Physics already has its results, its open questions, its ongoing arguments about interpretation. Not for the traditions. The traditions have their texts, their lineages, their practitioners, their centuries of careful transmission. The question is simpler and harder than what either domain asks. What does it mean that consciousness is one thing and matter is not separable into independent things, and two investigations starting from completely different positions, one with particle accelerators and the other with decades of silence, have arrived at the same structural wall? What does it mean that the unity which cannot be assembled from neural parts and the wholeness which cannot be distributed among quantum parts are the same shape? Found at the bottom of two of the most rigorous investigations in the history of human inquiry, found without looking for each other, found without either investigation knowing that the other had reached the same place. It means, at minimum, that the question is serious. It has earned its seriousness, not through comfort, not through beauty, not through the feeling of expanded connection that the popular versions of these ideas tend to produce. Through the work, through the experiments that closed every loophole, through the texts that most popular accounts do not read closely enough to reproduce, through the decades of inquiry on both sides that arrived at this shape by completely different routes and using completely different methods and with completely different standards of what constitutes a result. The question is serious. What it points at is not yet known. This is the honest position, and it is harder to hold than either of the comfortable alternatives. The materialist's position, which says consciousness is what neurons produce, and the mystery is not real but only incompletely explained, has the advantage of requiring no revision to the standard framework, only the assumption that the hard problem will eventually yield. That assumption has been held for a long time, and the hard problem has not yielded. The spiritualist's position, which says physics has confirmed what the traditions always knew, has the advantage of a satisfying convergence. Only it is not what the physics says, and it is not what the traditions say either, when both are read carefully enough. Both comfortable alternatives are selling something. The inquiry refuses the sale. And what the inquiry has instead is a specific, detailed, tested, contested, and genuinely open picture. What is established is specific, and it should be named with precision, not summarized. Named. Quantum entanglement is real. The experiments confirming it, from the first violation of Bell's inequality in 1972 to the loophole-free tests of 2015 to the Nobel Prize awarded in 2022, have been replicated, refined, and extended across 50 years and across every significant objection a committed skeptic could raise. The detection loophole, the locality loophole, the freedom of choice loophole. Each was closed. The violation held. Nature contains genuine, irreducible non-separability. The parts of an entangled system do not have independent states. The whole has properties the parts lack. This is not an interpretation. It is what every viable interpretation must account for, regardless of what else it claims. Decoherence is real. The mechanism by which quantum superpositions appear classical to observers embedded within them is understood with mathematical precision and confirmed by experiment. The classical world is not a separate domain from the quantum world. It is what the quantum world looks like from the inside of a particular kind of interaction, a particular kind of entanglement between system and environment that is stable, widespread, and extremely difficult to reverse. The classical is not fundamental. It is emergent, and the emergence is understood. That understanding is established. Quantum coherence occurs in warm biological systems. The photosynthetic light-harvesting complexes of green sulfur bacteria sustain coherence at physiological temperatures for hundreds of femtoseconds, far longer than the simplest application of decoherence theory would permit. The radical pair mechanism in the cryptochrome molecule appears to exploit quantum spin correlations in the navigational system of migratory birds. Whether these effects are genuinely functional, contributing causally to the organism's behavior, or whether they are byproducts of the molecular dynamics with no functional role is contested in both cases. But the prior assumption that warm, wet biology is simply too noisy for quantum mechanics to matter is not established. That assumption has been tested. It is not held. The binding problem is real. There is no convergence zone in the brain where the distributed streams of neural processing come together into a unified perception. The anatomists have looked. The neurosurgeons have explored. The unity of experience is not explained by any current neuroscientific framework, not by synchronous oscillation, not by global workspace theory, not by any proposal currently on the table. The hard problem, why any physical process is accompanied by subjective experience at all, has not been reduced by any mechanism proposed so far. These are not confusions about words. They are structural gaps between what the science of the brain can currently account for and what consciousness demonstrably, immediately is. These are what is established. They are not nothing. They are not small. They are the ground on which everything else in this account rests. What is suggested is something else, something the evidence points at without proving, something the structural shape of the inquiry implies without demonstrating. The unity of consciousness and the non-separability of the quantum are, at minimum, two instances of the same structural type, wholeness that cannot be recovered from its parts. This structural resemblance was not manufactured. It appears in the mathematics and in the phenomenology independently, without either field looking for the other. Whether this structural resemblance reflects a deeper identity, whether the mind's indivisibility is literally grounded in matter's non-separability, or whether the two are simply two cases of a mathematical shape that appears in multiple domains, is what is suggested, not established. Suggested. The no communication theorem is worth naming here. because it marks the limit of the suggestion precisely. Entanglement does not permit signals to travel between the correlated parts. Measuring one entangled particle does not transmit information to the other and cannot be used to link two minds across space, to share experiences, to create the kind of conscious connection that the popular misreading of quantum unity implies. The non-separability of the quantum is a fact about the structure of states before measurement. It is not a conduit. The structural parallel between quantum wholeness and conscious unity does not license any claim about minds being literally connected through entanglement. That is not the parallel. The parallel is architectural. The parallel is the shape of wholeness that cannot be distributed. It is not a mechanism. What is suggested further is that consciousness as fundamental is a live and serious option in a way that it has not been since the founding of the scientific tradition. The hard problem has not been solved. The combination problem has not been solved. Every physicalist proposal for explaining how unified experience arises from distributed processes has encountered the same structural wall. The proposals that begin from the opposite direction, that begin with awareness as primitive and explain the appearance of a world of separate objects as what awareness looks like from within a particular bounded perspective, have not been refuted. Their liabilities are real. They remain uncomfortable, but they have not been closed. That is suggested. That is not established. What is suggested is something else, something the evidence points at without proving. The unity of consciousness and the non-separability of the quantum are, at minimum, two instances of the same structural type. Wholeness that cannot be recovered from its parts. This structural resemblance is real. It was not manufactured. It appears in the mathematics and in the phenomenology independently, without either field looking for the other. Whether this structural resemblance reflects a deeper identity, whether the mind's indivisibility is literally grounded in matter's non-separability, or whether the two are simply two cases of a mathematical shape that appears in multiple domains, is suggested, but not established. What is suggested further is that consciousness as fundamental is a live scientific and philosophical option in a way that it was not 50 years ago. The hard problem has not been solved. The combination problem has not been solved. Every major physicalist proposal for explaining how unified experience arises from distributed neural processing has run into the binding problem, which has run into the same wall. The proposals that begin from the opposite direction, that begin with consciousness as primitive and explain the appearance of a world of objects as what consciousness looks like from the inside, have not been refuted. They have liabilities. They are not comfortable, but they have not been closed. The traditions that arrived at this position through entirely different methods, through decades of examination of awareness from the inside, left records of what they found that are not easily dismissed when the physics is held alongside them. The Chandogya Upanishad's instruction points at a non-dual ground prior to the appearance of many things. The Dzogchen lineage transmits the recognition of the single sphere of indivisible awareness, not produced by practice, but revealed by it. The Huayan school demonstrates that each part of a structure of mutual constitution contains and is contained by all the others without remainder. The Tao Te Ching opens with the principle that precedes all naming and distinction. These are not the same teaching. They reach the same structural depth by different routes, and the depth they reach is, architecturally, the depth that quantum non-separability describes from the other direction. This is not ancient wisdom predicting modern science. It is two investigations, incomparable in method, pointing at the same structural architecture. The pointing is suggested. The architecture is real. The identity of what they are pointing at is not proven. What remains genuinely unknown is most of what matters, and naming it precisely is the most important thing this account can do. The measurement problem is open. It has been open for 90 years, not because the physicists have not tried to close it. They have tried with extraordinary intelligence and precision, but because the question of what physically happens when a quantum superposition becomes a definite outcome is a question the current formalism cannot answer from within itself. The wave function evolves smoothly and deterministically according to the Schrödinger equation. Smooth deterministic evolution does not produce collapse. Collapse is an additional postulate, added to the theory to account for the definiteness of experimental outcomes, with no derivation from the theory's own structure. Three major alternatives to the collapse postulate have been developed over 70 years. Many worlds, which says collapse never occurs and the observer branches with every superposition. Objective collapse theories, which say a physical mechanism resolves superpositions at a specific scale and that mechanism is not yet described. Cubism, which says the wave function is an agent's belief state, and the question of what happens independently of agents is not a meaningful physical question. These are not equivalent. They disagree about what kind of thing the world is. No experiment available today can distinguish between them. The measurement problem is open, not open because unexplored. Open at the foundation. Whether the brain exploits quantum effects for cognition is unknown. OR is specific, detailed, and not refuted. It is also not confirmed. The experimental evidence that would distinguish microtubule quantum coherence from ordinary thermal motion has not been gathered. The decoherence calculation that Tegmark performed in 2000 has not been answered by direct evidence of the kind of coherence the theory requires, only by the demonstration that warm-wet coherence in other biological systems lasts longer than the simplest calculation predicts. The question of whether objective reduction at the gravitational threshold occurs anywhere in the brain over timescales relevant to neural processing is genuinely open. The question of whether Gödel's incompleteness theorems actually imply the non-computability of human mathematical understanding, Penrose's foundational claim, is contested by serious philosophers and logicians and has not been settled. These are the supports of OR. Each is unresolved. What lies at the foundation of consciousness is unknown. What the traditions have pointed at from the inside, the undivided ground, the single sphere, the substrate that is prior to the subject-object split, has not been mapped in third-person terms that physics can evaluate. The first-person reports are consistent across widely separated traditions, across centuries, across methods that cannot have influenced each other. This consistency is a kind of evidence. Its weight is genuinely disputed. It does not constitute proof of any third-person fact about the nature of awareness. Whether the structural parallel between quantum non-separability and the unity of consciousness reflects a mechanical connection or only a shared mathematical architecture is unknown. This is the deepest unknown in the picture. Because if the connection is mechanical, understanding one illuminates the other, and the two great investigations of the same question, from the outside and from the inside, are pointing at the same depth for the same reason. And if the connection is only structural, only architectural, then the two investigations have independently discovered a feature of the mathematics of reality that appears wherever reality is examined carefully enough. Both implications are significant. Neither is established. The question is open. And the question being open is not a failure. It is the honest description of where a century of extraordinary inquiry has arrived. We do not know, not as a confession of failure, as the most accurate report of where the inquiry stands. There is something clarifying about saying that precisely and letting it settle, and not reaching past it for comfort. The mind that has been following this account through the binding problem and Bell's inequality and the decoherence calculations and the photosynthetic bacteria and the hall of mirrors and the substrate consciousness and the single sphere has arrived at this, not at an answer, at a position in which the question is held with appropriate precision, without the false closure that either denial or affirmation would provide. The position is, something has been found. We do not know what it is. The finding is real. Now the strongest case against everything that has been built here. It deserves a fair statement, and it deserves to be taken seriously, not as a foil, but as a genuine check. A careful materialist would say, structural resemblance is not evidence of shared nature. Thermodynamics and information theory share mathematical structures. The equations governing the spread of disease through a population and the spread of rumor through a social network are formally identical. The universe contains many instances of the same mathematical patterns appearing across completely unrelated domains. Finding that the unity of consciousness and quantum non-separability share an architectural shape is, on this reading, not surprising and does not constitute evidence that one is related to the other in any physical sense. Mathematics is more general than any single domain it describes. The comparison, however striking, does not prove that the mind's indivisibility has anything to do with quantum physics. It proves only that the same mathematical structure can be instantiated in two different systems, which is true of many mathematical structures, and the materialist would continue. The contemplative traditions, however rigorous their methods from the inside, are first-person reports. First-person reports under well-controlled contemplative conditions are valuable as phenomenology, as accounts of what it is like to engage in intensive examination of experience. They are not third-person measurements. Longchenpa's account of Rigpa and Bell's theorem are not the same kind of claim. They are not even candidates for the same kind of comparison. One is a report of what a trained practitioner found when examining awareness from the inside. The other is a mathematical inequality, whose violation has been measured by instruments in controlled experiments. Drawing a structural parallel between them is meaningful only as a remark about the shape of the language used to describe them, not as a remark about the world. The traditions are pointing inward. Physics is pointing outward. Both investigations are real. Their results are not commensurable. This is a legitimate objection. It is probably the strongest version of the skeptical position. It should be held without deflection. A strict traditional practitioner, someone formed in one of these lineages who has spent years working with what the texts transmit, would object from the other direction, and the objection is equally pointed. The entire project of drawing parallels between the contemplative investigation and physics misunderstands the nature of the contemplative investigation. The traditions are not describing a feature of the physical world that physics might also describe. The traditions are describing what is prior to the domain in which physics operates. Physics is an investigation of objects, of what shows up when one system measures another, when interaction produces a definite outcome, when information is registered and stored. The ground that the traditions point at is prior to the object-subject distinction on which all of this rests. It is not a quantum phenomenon. It is not a feature of space-time. It is what awareness is when the construction of observer and observed has not yet occurred. Comparing it to entanglement is a category error, subtle, attractive, and wrong. The finger pointing at the moon is not the moon. This objection is also legitimate. The traditions themselves would affirm it, and it should be held alongside the first. The position this account holds is not between these two objections. It holds both simultaneously without resolving them. The structural parallel is real and architecturally precise. The two investigations are not commensurable. Both of these are true. Holding them both is more demanding than collapsing into either. It is also more honest. We do not know. Not as a confession of failure, as the most accurate report of where the inquiry stands. There is something you already know about this, though it has perhaps not been named. You have been in a room at night and felt the room not be empty, not in the way that fear populates darkness with imagined things, in the way that the absence of noise and activity leaves something present that was there all along, but could not be noticed through the ordinary traffic of the day. A stillness that is not the absence of sound, but the presence of something the sound was covering. The word for that is not mysticism. It has no name that fits it perfectly. It is a recognition, specific, quiet, not arrived at by reasoning. You have noticed at some point in a life that the ordinary explanation of coincidence does not account for everything that appears to be coincidence. Not because the coincidences require a supernatural explanation, because the precision of some of them, the timing, the structure, the sense that the event was somehow answering a question, produces a quality of attention that the word coincidence does not capture. This is not evidence of anything. It is the felt texture of a life that is not explained by the simplest account of it. The felt texture is real. Its interpretation is open, and you are aware. Right now, in this moment, whatever the moment holds, the darkness of the room, the weight of the body settling, the sound that comes and goes, the breath that is slower than it was an hour ago. There is something it is like to be here, not something you are doing, something that is simply occurring. The field of awareness is present. It was present before this thought arrived. It will be present after this thought passes. It does not begin when the thought begins. It does not end when the thought ends. It is what the thought appears in. That is the hard problem. Not as an academic puzzle, but as the immediate fact of what is occurring. The ground being investigated is the ground that is doing the noticing. The question of what awareness is cannot be answered from outside awareness. The instrument of the investigation is the object of the investigation, and this is not a problem to be solved. It is the structure of the inquiry itself recognized. What the physicists found with their instruments is that the world at its foundation does not consist of separate things with independent properties. What the contemplatives found with their attention is that awareness at its foundation does not consist of separate moments with independent contents. The separation that appears in matter and in mind is real at the level at which it appears. It is not the full story of what is. This is not a conclusion. It is a recognition of what was present throughout. The physics has established what it has established. The traditions have pointed at what they have pointed at. The structural parallel is real. The meaning of the parallel is open. And at the bottom of both investigations, the one conducted with particle accelerators and the one conducted with decades of silence, there is the same feature of the world that will not reduce, that cannot be assembled from its parts, that is always already whole. It does not require a name. Names have been offered: Rigpa, Turiya, the ground state, the substrate, being itself, the Tao, the open question. Each name is a finger. Each finger is not the thing it points at. Whatever that thing is, it is not distant. It is not produced by any method. It is not achieved by understanding more, or meditating longer, or learning the correct interpretation. It is what is aware of the method, the meditation, the interpretation. It is the field in which the inquiry arises. It is what is present when everything else settles. The sound of the room, the weight of the body, the thought that was forming and is now releasing without needing to complete itself. The awareness that remains, not as an experience that has arrived, but as the ground that was here before any of the experiences began, and that will be here after each one ends. The investigations on both sides have found the same wall, not the same wall in the same way, through completely different methods, with completely different instruments, in completely different centuries, arriving at a depth that neither the laboratories nor the monasteries expected to reach by the route they were traveling. The wall is real. The wall is not a problem to be solved. It is the ground. The whole is real, and the parts were never separable. And whether that is a fact about particles, or also a fact about the one who has been aware of them all along, is the question that remains here, in the dark, undivided.